Okay, this is problem 4, and problem 4 is actually another easy problem. It's just you need to be very careful with your geometry here. It's asking you to find the critical largest load P that can be used, and for that you need to use the critical force equation, which is given in your notes here. Yes, it's given for buckling here. And recall that for buckling only occurs in compression. So looking at this, I don't know if you can tell right away, but you should keep in mind that in this particular case, the only two items that are in tension are this beam here and this beam here. There's not much I can go into without giving you the full solution, but I will tell you that you should be very careful with your notation. The formula uses over L squared. Oh, it uses LE here. LE is effective length, but in this case you can just assume that LE is equal to length. That should be fine. But be careful when you use this, because this refers to the length of the member, but the length of your member will not necessarily be L. Or I don't want you to get confused and think that your thing, for example, like this here, this is L over 2, and this is L here. This is not the L. If you want to plug this in here, you need to use 0.5 L. So for example, for PCR equals EI pi squared, make sure, yeah, this is very basic. I don't want you to make this mistake. Because you're gonna end up, your lengths, the first thing you want to do is probably find the lengths, and then you want to define these angles. So like this angle, you could probably tell right away that this is 45, 45. This angle is going to be something weird. It's going to be a little bit more than 45. I won't tell you how much more, but it'll be just a little bit more than 45, and you should be able to figure this length out. Once you have this, you should be able to figure this length. You should be able to figure out that angle. And then I would label these beams. Yes, I would label these. So you can label this, I don't know, you can label this as 1. The professor uses 1 and uses 2 here. And you do not worry about the bottom beam, because the bottom beam will be in tension. And if you can imagine this, it should be pretty easy to imagine why this is in tension. If you have something like this, where it's free to roll, this is free to roll here, putting a force on here causes the thing to essentially do the splits. That's all there is. Like it forces, because this is a roller, this thing starts sliding away. So you can imagine that this guy's foot is against the wall, and then this other foot is on the floor, being his body weight is just, I don't know. Yeah, you guys get the picture. This thing will always be in tension. And yes, keep in mind that the diameters of these beams, of these two poles, I guess, are not the same. This uses a thinner diameter, but it's also smaller. When you're done with that, once you've labeled all these, once you've gotten the angles done, you want to do summation of forces. About, say, okay, the professor labels these A, B, and C. You want to do summation of forces, and you'll get components here. What you're ultimately looking for is you're trying to find your forces. You'll get forces, let's say that this is like this. You'll get forces that are like this, but you want to find the force that goes in line with the beam. And you can use this. You can find this with some trigonometry. Yeah, so find p critical in 1, find p critical in 2. I'm debating whether I should give you a little bit more information, but I think that's okay. You have the equation for I again as given in the problem in the cheat sheet, if you will. I is here. Keep in mind that when you're over 4, this diameter is not d. So, for example, 0.75 d divided by 2 equals r. So you need to put this whole thing to the 4th. Not just however you're going to do it, but make sure that you include everything and you put everything into the power, not just the d over 2. And that should be everything. Part B of the problem is just asking you to up here you're going to find PCR in terms of e d to the 4th over L. You're going to have it in units of this, or it's going to be in terms of this. You're going to have some times constant, and you're going to get this for 1, for 2. You're going to choose whichever one is larger, and then given part B is just plugging in the information and finding what P max is allowed to be. Yeah, so that should be pretty straightforward. Let us know if you have any questions.